Hello, everyone, and welcome to ROG Pulse, the Republic of Gamers podcast, where we dive in and talk about, well, pretty much everything ROG. This week, we're talking about liquid metal and how we've mastered it as far as we can for our laptops at the Republic of Gamers. Guys, my name is Solid Jake, GG, also known as Jake Kalinsky in the real world, and I'm joined here by Ryan and Sascha once again. Friends, good morning over there in the land of Asia. How are things? Oh,
Nick, it's great. How are you?
Can't wait for the weekend.
yeah, it's Friday for you guys. I'm good. I'm excited to sit down and talk about. I can see we've got some devices right in front of you here. We got some motherboards for which laptops. Do you know which laptops these go to?
Yeah, so this one is the Zephyrus Duo motherboard, the bigger one,
Yep.
and the thermal module on top of it. And here we got the G14, our G14 motherboard and thermal module.
Very cool. So basically, guys, we're going to go in, we're going to talk about what liquid metal is, how liquid metal differentiates from thermal compound. That's actually my first question because I don't even know the answer to it, and how that's applied. Can you do it at home, and the whole deal. And this is a process where, as far as I understand it, we've put in a lot of research from the engineers, and it's going to be interesting to see exactly how this goes down. So, Sascha, what exactly is the difference, or Ryan, whoever wants to jump in first, with liquid metal versus thermal compound?
Sasha, you can take it off first.
All right.
Yeah.
So regular thermal paste is silicon based. The reason for that is that it lasts really long and it stays somewhat viscous and liquid, so it can fill in all those tiny gaps. So the main reason you need thermal paste is because no matter how much you polish a heatsink to make it super flat, the chip surface is also super flat. It's still not flat enough to have really 100% contact. So there's always gaps in between. So you need to fill those gaps to make sure the heat can move from the chip to the thermal module. And yeah, silicon does that really well. It lasts really long and can fill those tiny holes. And for some thermal paste, you add aluminum oxide, so some basically metal powder that helps to fill gaps better and move the heat faster. And then liquid metal is actually an alloy called Galistan. Galistan. Sounds like a country.
Sounds like a
But,
Lord of the
no,
Rings
that's-
person.
yeah. But that's the alloy, the name of the alloy, and it's a mix of tin, gallium, and indium. So those are three different metals with different melting points, and generally those metals, at least the gallium and the indium, can be liquid at room temperature. So just as from a thermometer, like really old thermometers, you have some mercury in there or something else, liquid at room temperature. So that's basically what liquid metal thermal paste is about. And because it's a metal, it can conduct heat really well.
Even better than
Yeah.
Oh yeah, much better than traditional thermal paste, much higher. It's I think like 10 times or 20 times higher thermal conductivity, though in reality, once you put it on a heatsink, it's not like you get 10 times or 20 times better conductivity through the whole cooling system. But yeah, it basically eliminates the main limiting factor for cooling is the contact between the chip and the heatsink, and liquid metal eliminates that as a bottleneck.
So Ryan,
Yeah, and one of the special things. Oh yeah, go ahead.
no,
Sorry,
you go ahead. You go ahead.
Oh, so one of the things that is special about liquid metal is that because you know, it has a low melting point and a high boiling point, so that's why at room temperature it's still liquid. And so basically, that's one of the reasons why the compound remains liquid at room temperature. So there's basically no evaporation due to it having a very high boiling point. So even when you have this inside a laptop and the CPU is heating up, the GPU, the thermal module is getting hot.
Right.
It's still able to maintain its state and it's able to efficiently transfer the heat from the CPU to the heatsink. And
Yeah, there were some people who were worried that it would evaporate away because if it's liquid at room temperature and then it gets hot, then maybe it just evaporates because mercury, it does evaporate over time, right? But this does not. Indium, gallium does not evaporate over time at room temperature, even at higher temperatures. Yeah.
Science. So I haven't built a PC in like 4 years. Is this becoming the standard for like a home built PC, or is this something we're only seeing in laptops in special cases?
I think it has become more and more popular. I think the first time I heard of liquid metal was 15 years ago or something. It was very niche back then, and kind of like voodoo magic, and only enthusiasts would talk about it, and everybody else wouldn't really know what it is. And they would, like, you could show them, they're like, "Wow, what is this?" Um, but over the last, I think, 10 years especially, yeah, it has become more and more popular and more common. Mostly I think PC DIY, and for desktops, high-end desktops, enthusiasts are using it. But then in laptops, it's starting to become more and more popular as well. And that's something where Ryan can tell us about his experience.
Yeah, so like Sasha was saying, it definitely is more of an enthusiast. You know, the types of people that would actually apply liquid metal to, especially a laptop. I'm sure there's more PC DIY people that would actually do
Yeah.
it, but when you're talking about a laptop, there's a lot of factors you need to consider, and you don't even know what type of heatsink it might be, and that kind of factors into whether you can use liquid metal or not. Me personally, I did use liquid metal myself on a laptop that I owned several years ago, and that's mainly because I was just you know searching around online and seeing like what I could do to improve the temperature, or should I say more importantly the performance of the laptop. So yeah, I looked up some stuff and was like, oh yeah, why not try liquid metal? So getting into the laptop, really preparing, and like you have to really set it up. Like I personally, at first I used nail polish to paint around the CPU die, and then I also applied electrical tape around the CPU, and then only then did I begin to even think about applying liquid metal onto the die. But yeah, it's definitely not the easiest type
Oh
of
yeah.
material to apply. Like the moment you even squeeze it out, like you think it's gonna go in the direction of the actual, where it's pointing, but it kind of just goes the other way. So I did spray some liquid metal onto the motherboard and gave me a mini heart attack, but
Oh,
I
geez.
quickly just, you can using the exact same tool, you can just suck it right back up and
That's the thing. Like on a desktop, it's much easier to remove the heatsink and put, different thermal compound on there and putting it back. But in a motherboard, you have to disassemble the whole thing, and that's much harder to do. So yeah, there's much less people applying liquid metal in laptops, and it's much more tricky. So the thing with any metal, it conducts heat really well, but it also conducts electricity, right? The two kind of go hand in hand. And so that's something you have to be very careful with liquid metal. You have to make sure that it doesn't touch anything else on the motherboard or even on the CPU package. We'll get into that later, because it potentially shortens and then fries your laptop or your PC. And yeah, if it does go everywhere, like it happened for Ryan, um, you can still clean it all up and get rid of it, but you just have to be careful. You have to make sure you find it all, because there might be a small pearl of that liquid metal hiding somewhere, and then once you turn on the laptop, it fries the laptop. So you have to be very careful with
Wow.
this. And yeah, liquid metal, just like mercury, it pearls up. It has a really high surface tension. So once it's not like normal thermal paste that you can just spread like butter, pretty much, but it pearls up like crazy. We'll show on camera in a bit. Yeah.
I don't see why we should hold off. Let's just jump right into it and talk about how this
All
is
right.
actually applied. We're talking about the do's and don'ts and how it can be tricky. So I would imagine we have machines that have automated this process for us.
Yes, correct. So for regular thermal paste, there's two ways of applying it. You can either have it as a paste that you apply on the heatsink, and you apply it on the heatsink, not on the CPU or GPU. So what happens is you have a stencil essentially that you put over the heatsink, and then somebody manually applies the thermal paste to the heatsink and then removes the stencil. Or you can have some special pads like these, where the thermal paste is applied to these little pre-application slips, and
Hmm.
you put that on the heatsink and then apply it that way. So that's how you do regular thermal paste.
Right.
For liquid metal, obviously, since it's so difficult to do, we knew that precision is super important, because also if you apply too much, then that's going to go everywhere and short the motherboard, right? So that's why we came up with first these little tools here. So we have some experts in our thermal team that created basically a prototype for the applicator to apply the liquid metal. And this is the stencil. So first, you put the stencil on the CPU, and then you apply the liquid metal. And we experimented with many different ways. The most difficult part is breaking the surface tension of the liquid metal to make sure it actually spreads all over the silicon die. So after a lot of different trial and error, we found that rubber works really well. So it's a bit like a windshield wiper, essentially. It's like a little piece of rubber, very soft rubber, and it just keeps going back and forth and spreads that liquid metal carefully over the
So it's
CPU.
just a mini squeegee to rub the metal
Yeah.
perfectly.
Pretty much. So that was the prototype, and then we built our own machines that apply this. And we have a really cool video that Sanji from my team made about this application, and that shows all the process step by step in a really cool way. Yeah, something else we found out is we need to make sure first, because like I mentioned earlier, it's highly conductive. I don't know how well you can see it on here. We can't really zoom in, but there are still some metal pads on the CPU package. So this is the CPU die, the silicon die, and then this is the package of the CPU. And on there, there's still some gold contacts, some gold pads. Those are used for debugging. So when the wafer is cut and then each individual CPU is placed on its packaging, those pads are used by Intel or AMD or NVIDIA to check if that bonding was successful, if the CPU silicon die or GPU silicon die actually bonded and is soldered properly to the package and is working properly. But we need to make sure there's no liquid metal on those, because that's going to short the CPU or GPU as well. So
Right.
the first thing we need to do is apply this special tape. This is something that we figured out ourselves the hard way as well. What this tape is called
Captain.
Capcom.
Capton.
Capcom. Yeah.
Tape. Yeah.
Like Capcom America. Yeah. It's called Capcom. It's a special brand tape. What's special about it is it doesn't melt or deform until 300 degrees Celsius. So it can get crazy hot and doesn't change shape. And we
So-
put this tape on top of the CPU package. And you can see it has a cutout. It's about the same shape as the CPU die. So it protects everything else on the CPU package from getting contacted by the liquid metal.
Wow. So it's just going to hold it and make sure it never escapes. That's pretty cool.
Right. So the first step is applying this tape.
Yeah.
Then the next step is we put the stencil over the CPU and then spread the liquid metal. But I mean, I'm just showing it here manually. We have a machine that actually does
Well,
that.
I
in
actually
effect,
do.
several machines.
I can actually show the video.
Oh yeah.
So
Yeah, that'd be perfect.
Yeah, that'd be great.
Just to kind of show it.
so we can actually just kind of see the process.
So there's the stencil. Then this is the first machine.
And that's the swiping mechanism.
Okay.
Yep, that's the wiper.
And that's a rubber tip.
Yep.
Yep.
So that's the final machine, and we have the prototype here.
Yeah, so the things that we have here are like very early prototypes, and this is probably the first version that they made of
Yeah. And
Thermarty
that was the second machine. So you can see it then injects some additional liquid metal to make sure there's enough. So first we just put some on to just break the surface tension and cover the whole surface, and then next we inject some more to make sure it's really all covered and there's enough to fill the gap between the heatsink and the CPU as well. And then the final step is putting the heatsink on. And then for the heatsink as well, there's something we made sure works really well, and that's for longevity. Let me try to find a good angle. There we go. You can see that the CPU cold plate of the thermal module is silver, while everything else is copper. The cold plate is actually copper as well, but it's nickel plated. And the reason for that is what happens with liquid metal is those metals start to corrode and have a chemical reaction with copper. It's a very slow process, but slowly over time, what you'll see is that the liquid metal disappears. And people are saying that, oh, you need to reapply liquid metal like every 1 or 2 years because it evaporates. So that's where this lift comes from. It doesn't evaporate. What actually happens is it slowly eats inside the copper, and it's like it kind of eats a sponge structure into the copper, and then slowly dissolves into the copper itself. So to prevent that and make sure everything works properly, we added a nickel plating on top. So with that, there's no corrosion, and it lasts for many, many years, and it doesn't evaporate either. And another thing we had to do is add this foam, this rubber, well, not rubber, this
It's basically a sponge material.
sponge, yeah.
Yeah.
A sponge around the CPU cold plate that makes sure that the liquid metal doesn't leak out. Because again, it can't just short the CPU package, it can short anything on the motherboard. Like what happened to Ryan when he was applying it, it went all over the place. And with a laptop, the desktop, it's just standing on your desk, so it's not really a big deal unless you tip it over or your cats or dogs tip it over. But with a laptop, you take it with you everywhere, right? And it's like you have it in your car, you drive somewhere, and it's like shaking around like crazy and vibrating. You take it on a plane, the pressure changes, temperature changes. So to make sure none of the liquid metal leaks out and goes anywhere in the laptop for several years, it has to be super safe. So that's where this foam gasket comes in.
And actually, with this little foam sponge material that we have on the thermal module here, Thermal RD went through like several revisions of this, and it was
Yep.
very difficult for them to actually figure out like what type of material and like exactly how thick it should be and how dense it should be. Because if it's too dense, then it'll actually lift the thermal module too far from the motherboard.
Yep.
And if it's too far off the motherboard, then the liquid starts seeping out. And also you need it to be like a certain thickness in order to maintain that integrity, so that basically this creates a nice seal. This sponge material creates a nice seal with this part of the CPU die right here. And so that basically allows us to ensure that the liquid metal does not seep out and go into your motherboard and create any electrical shorts that will fry your system. So it was a very very peculiar process and definitely very hard. And our thermal
Yeah.
RD put in a lot of work into making
Yeah.
sure
Yeah.
that any of this, like, liquid metal is a very difficult substance to work with. And
We
they
started working on this like 3 years ago. So and we only rolled it out like in mass production on all our ROG 10th gen laptops this year. So it really gives you an idea of how much work and effort has to go into this. And I think a lot of people don't understand why it's so complicated, because on a desktop PC it's much easier to do. And if you apply it yourself, it's fine. But it probably takes, like, how long did it take you to apply liquid metal? Like an hour, maybe more.
I think more.
More than an hour, yeah. And it's
Oh
just,
my.
in an assembly line, mass production, you can't do that. It's really, really expensive. And then if something goes wrong, then what happens to that laptop? How much time does it take you to clean it up? And or maybe it's just lost. You just have to throw it all away. So that's it's very difficult to mass produce something like this. And I hope everybody appreciates all the hard work our engineers went through to make this happen, because we've been pushing for this for a while, and they were like, "Oh, this is a nightmare to work with," and "Oh God, please don't make us use liquid metal. It's so difficult to work with, and the risk is so high. It's so dangerous if something goes wrong." And yeah, it took us a long time to really get there.
Okay, so this is clearly a lot of work and a lot of effort to make this happen. What is the actual gain? Like, how much of an important performance increase am I looking to see from this versus thermal compound?
Remember from your laptop how much of a performance, like clock speed went up by? I mean, it
I'd say
depends.
on average, there's a lot of factors with this, because
Yeah.
typically people have a misconception that liquid metal is gonna significantly decrease your temperatures. And so, in some cases, depending on your CPU, the way your thermal module works, it may lower it a bit. But I think one thing you have to keep in mind is that when the temperatures are lower, especially for the CPU on Intel CPUs, the CPU is going to boost for even longer, because you're giving it more headroom.
Hmm.
So basically, if your CPU is cooler, I'm just giving random numbers. Let's say it's at like 75 degrees, then your CPU is thinking, oh, I can turbo clock to the boost clock even longer. And so actually what ends up happening is that your temperatures may rise a little bit. But it really depends. And on average, for me personally, I think I had like a 10-degree drop, and also about a 10% performance increase overall on my personal laptop.
Mm.
Um, so I that obviously these numbers depend, and how well you apply it also is a big thing. Like you need to put the right amount. You need to really coat the entire the
Yeah.
CPU die. Traditional thermal paste, you're just going to basically be putting, like, depending on the way you like to put on thermal paste, you could just do like the P dot method. You could do the line, or there's like even an X method.
There's so
I
many
think those
different
are a
ways.
little
Yeah.
too. Yeah, there's a little too many different ways, and I usually just did the P
I'm
dot
a P
method.
guy. Yeah. Yeah.
Yeah, I'm a yeah. So with that case, like it doesn't you don't need an exact amount of like in terms of how it's spread on the CPU die. Like generally, when you put the heat sink on top of it, that's good enough to allow it to spread.
Right.
Obviously, you don't want to put too much and you don't want to put too little. But with liquid metal, you need to be very meticulous in how you basically apply it onto the CPU die. You really need to spread it evenly. You need to make it have like basically it needs to look really shiny on top. And once the liquid metal looks like it's shiny, because you can tell when it's not, it's kind of like rigid and you haven't spread it well enough. But once it looks like that, and that's when you can begin to apply the thermal module on top, the heat sink.
Yeah, it really depends because, like I said, for the thermal module, there's different factors that limit the cooling potential, right? Like how many heat pipes you use, what kind of heat pipes you use, the quality, and if using copper or aluminum, how big is the surface area of the heatsink fins, how much air are you blowing through the heatsink? So all of that stuff adjust like how much where the limiting factor of the thermal system is right now. And depending on if you're running, for example, mothership, ROG mothership was the first system where we used liquid metal. And in there, for example, if you use silent mode, then obviously you get very different results when it comes to performance and temperatures as if you run the laptop in turbo mode. And I remember from mothership, we saw a surprisingly high temperature drop of up to 22 degrees on the CPU, but that depends on the scenario. And on average, I think it was like a 400 megahertz higher CPU clock in games, and extra FPS in games as well, and lower temperatures. So yeah, it depends on the overall system. But an average, I think, yeah, like 5 to 10 degrees lower CPU temperatures, and you get a performance boost of 5 to 10%, something like that.
I mean, yeah, that's significant. That's definitely worth the effort to go the next level. And a lot of people at home are probably saying, maybe with my new dream machine that's going to rock a 3080 if you manage to buy one today, maybe you want to try to do this on your PC. Answer is probably no, based on what I just heard. But if you're a hyper enthusiast and you want to take the challenge, we can see some of the tools here on the desk. Are these the products that are just readily available to anyone? Could you buy this tape, or is that something we've made exclusively for our devices?
Oh, that tape, I don't think that's something that's available
I
in the
figured.
retail market.
Right.
Yeah, so what you can do is like what Ryan did. That's what generally enthusiasts do. That's what I did way in the back in the days as well. Even for water cooling, or as soon as you go close to room temperature or below room temperature, you want to make sure you isolate everything against condensation and or electrical shorts.
Right.
So nail polish works super well. We actually experimented with that as well. So we had like some small nozzles that sprayed nail polish or something similar to nail polish onto the CPU package when our thermal engineers were researching this. And the problem with that is um, even after applying 10 layers of that coating, there were still some capacitors on the CPU package that would, or the gold contact on the CPU package would still get affected by the liquid metal. So that's
10
why we went
layers.
for the tape. Yeah. But I think they had to go for a very thin version of the paint to be able to spray it with a nozzle. So yeah,
Yeah.
that's probably one of the reasons.
Ryan?
Well, you also have to keep in mind that this is an automated process with so most people that are enthusiast DIY people, they're going to be applying it manually. And so you can tell like when they apply it, there's a lot that's going on. But in the machine, like, an automated process, they had to figure out how to way to do it because you can't have, if you're doing this one at a time, one person, putting on nail polish, it's going to take way too long. And manufacturing this many laptops, you need to make sure that you have some efficiency. So with this type, with the machine automated process, they went with the spray. And so, but with the spray, unfortunately, sometimes with that type of process, you basically the amount of nail polish that actually gets applied, it actually starts to fall off of the capacitors. And so that's one reason that we didn't go with nail polish.
Yeah, and you can do this at home. Anyone can do this at home. This is actually the thermal compound you can buy in retail. We buy the same one, just in much higher quantities. We buy it in buckets and not in small packs like this one. Yeah, Thermal Grizzly conducting out. Quick shout out to the Bauer who we work with together on this. So they're kind of the experts in liquid metal. And yeah, anyone can buy this. It's more expensive than regular thermal paste, but I mean, it's not that expensive, and it's definitely worth it if you want the best thermal compound. So yeah, we can try to apply it now. So this
Yeah.
is you get a little bit of an unboxing here.
Disclaimer: it's been a while since I think either of us have applied it. So
So yeah, it comes with what's that? Discount coupon. Um,
Nice.
So yeah, it comes with Q-tips. So that's with a cotton swab. That's how you apply it because you need to spread it and break the surface tension. So instead of using a wiper like what we use, this rubber wiper, it comes with cotton swabs. And I can just try to apply it right here. The micro tip, yeah, not the regular one.
yeah, definitely use the microtip.
Actually, a tip from what you should do, you should not try to apply it directly onto the CPU or GPU, because then what happens is what happened to Ryan. It bounces off and just goes anywhere because you need to squeeze a
So
bit hard.
one thing you could do is you could test it on like a
You want to do
tissue
it?
or just see how it comes out. Yeah, and one thing that's cool about these ones is that these are special types of Q-tips, and basically, me personally, you can use normal Q-tips, but I just feel like those ones have too much lint on them, and so these ones are really wrapped in a way that there's not much lint, and when you start
Yeah.
spreading it on the CPU die, you really this type of Q-tip is better, and so you can buy these in stores, and obviously when you buy it from Thermal Grizzly, they do include two as well. So one thing I like to do is I like to just squeeze it out first onto like a napkin first, just see how it spreads. And so right now
That worked really well.
that worked really well, but sometimes
Yeah, yeah, it's
it
stuck.
doesn't.
Nothing comes out, and then you squeeze harder, and it just
Sometimes it doesn't go that way. So,
yeah.
anyways, it's really easy to just suck it back up, and you can actually use the other tool to suck it back up. So let's
You want to apply it? Let me put some on the Q-tip and then put it on.
you want to do it that way? Okay, sure.
There you go. See, it's even hard to just get it on the Q-tip.
Me personally, I prefer to just
Come on.
I would just use this tool and push it back into the tube.
Oh, it's sticking to the paper so well. I didn't use paper
Let's
last
just
time.
okay.
Some now.
The better method though right here is just to suck it right back up with this tool. Cool.
Yeah, I don't know how much you can see on the camera since it's not too close, but um, I hope you can see that it's slowly spreading, and it kind of looks like you're just smearing some silver grease on the chip at first. You just need to make sure there's something on the CPU die first, and then later you just add more to it. Yeah, I'm just putting it on the GPU right now.
Okay.
Bigger die, easier to work with.
Typically, we just wanted to see that it comes out like correctly onto the
Yep.
tissue because
Oh, you can
obviously-
see it on the camera, right? Yeah, it's
Yeah.
reflecting the light.
So
So.
let's put some more on there, but
So at first you might feel like, oh, nothing is sticking to the surface. You just keep swiping. Well, that's a lot. You just keep swiping over the chip, and you'll see that there's some kind of a grease stain on the chip. And then as you apply more and more, you'll see that the grease covers the whole chip. And then when you add more liquid metal, like Ryan did just now, it then connects to basically all the grease film of the liquid metal that you already applied to the whole chip. So
I
you
think I
can
applied
see,
just the right amount.
yeah, I think, and this is maybe a little bit much, but I think it's perfect for show. It looks
Well,
really cool.
you really do. When you apply liquid metal, you really do want to coat the entire thing, and so that's why, at least when I did it back then, you have to really be careful with how you isolate it. So you really do need to put like if you're doing it DIY, you need to have like tape. You
Yeah.
can even go nail polish on top of that.
And
But
yeah,
yeah,
we said it takes over an hour, but mind you, we've done this a few times, so I think that's why it's faster for us now. And then also we didn't do any preparation. We didn't put any nail polish on there and any tape. So yeah, you need to, for the nail polish, you need to wait for it to dry and apply another layer probably.
well, when I
It,
say 1 hour, I also included like
it sounds
actually
like painting a
disassembling the
house.
laptop. Yeah.
Oh,
Well,
it looks really cool actually. You can see it on the camera. So yeah,
Yeah.
there's the liquid metal. You can see it even moves as I move the
Wow.
motherboard around. There you can see it. And yeah, you can imagine this would run off really fast and touch any of the small SMD surface mount capacitors on the GPU package right there.
Hmm.
And that's also why we don't use it on a GPU right now. So one reason is GPU. The difference between a CPU and a GPU is that on a CPU you have generally now 6 or 8 cores, and each of those cores is a hotspot and gets super hot. So you have much more hotspots on a CPU as you have on a GPU. On a GPU, you have thousands of individual cores that all do different tasks. And that's why the heat is spread much more evenly on a GPU. So you have less problems with hotspots. And
Mm.
GPUs generally have a much larger surface area as well. So it's easier to get rid of the heat. So if you look at the power consumption, you would think cooling a GPU is harder because they're generally like 100 watt, 150 watts, and CPUs are only 35 or 45 watts. But because the silicon die is way bigger and the heat is spread much more evenly on the silicon die, it's actually easier to cool the GPU than the CPU. The problem with the GPU, however, is you have all those SMD capacitors on the GPU package right next to the silicon die. And even if we put that Kapton tape on there, it would leak under the Kapton tape and still contact them. And even if we're painted, it would still contact it. So it's very difficult to put it on GPUs. And that's also why we didn't put it on AMD CPUs right now. So I can reveal right here, this is a Renoir CPU. So it's a Ryzen 9 4900HS right here. And you can see it has a lot of small SMD capacitors right next to the CPU as well. So that's why we don't use it on there right now.
But Ryan, technically possible. It would be possible to do this with an AMD CPU.
yeah, we're well, our thermal RD team is looking into it, and I mean, no promises, but they definitely are trying to figure out a solution that allows it to be possible and to avoid, making contact with the capacitors that Sasha just pointed out over there. And so they're looking for a safe way to ensure that that can be done at an automated process in a factory. So, like, granted, I'm sure there's a way to do it, one by one person doing it with their hands, you're applying certain materials around it. But in an automated process, you really have to make sure that, whatever we're doing to protect the motherboard from it is really consistent
Right.
for every single motherboard because we're producing these at, you know, thousands of laptops. So,
And you can see actually on this thermal module of the G14, for people who paid attention, the cold plate of the CPU is silver. So, and we have definitely experimented with it and we have definitely tried it. Um, it's just a matter of time until we manage to find the right materials and the right process to make that happen on GPUs and AMD CPUs as well, I think.
So I actually one thing with the liquid metal that we just applied. So one reason that I actually put extra on there is that I do think it is better because it allows you to spread more. So you shouldn't worry too much if you have too much, but basically you do want to make sure that it is completely covering the top of the
Yeah.
die. And if you really do to have too much, like you put too much on there, you can just, use a little tool and suck back some of it up. So
Yeah. Yeah.
it's in my opinion, it's better to put, a little bit extra and then you really make sure that it starts to coat on top of the entire surface of the die. And Sasha is trying to make it fall off.
Yeah. So this is what it looks like. Liquid metal gone wrong. We can do this because this motherboard is dead anyways. So this is what it
I don't know
would
if they
look
can.
like. I think you can see if I find the right angle where it reflects the light. A little bit more. There you can see it.
Yeah.
Yeah. So this is what would happen. You have this liquid metal all over the place, and it gets stuck between the legs of all the different components. It can even creep under the package of the memory chip, so you can't even clean it anymore at all. So that's why it's really important to make sure it stays on the CPU and GPU die only and doesn't go anywhere else. And yeah, you can still clean this up, but that's
it just
Not
becomes
fun.
more annoying. So you basically just have to like start, using your little tool here. You suck up as much as you can, and
So who has to clean
yeah,
these
it's a
motherboards
it's
up
a
later?
meticulous process to say the least. But yeah,
That's okay. I made the mess. I'll clean it up later. Don't worry about it. We have to return this liquid metal to a friend we borrowed it from. Hopefully
yeah,
he doesn't
it's
watch this.
pricey. It's pricey stuff. Yeah. So yeah, that's basically what you do, and then you can, yeah, basically just make sure you're not connecting to power. Just connect the battery if you can, and just don't turn it on if you know
Yeah, yeah.
spill some liquid metal onto your motherboard. So
Don't want to be frying anybody's motherboards at home, especially with a lot of new builds happening right
Yeah,
now.
and then also, if you do it on a PC DIY, if you build your own computer, you apply liquid metal probably on the CPU, and there's much more space from the CPU itself to the motherboard, so there's a much lower chance that it's going to leak out. Um, and it's even if something goes wrong, you can probably clean it up more easily.
Right,
But
right.
even if something goes wrong and let's say the motherboard dies, then okay, the motherboard is broken, which sucks, but it's at least only the motherboard. But if you're doing this on a laptop,
It's
you
everything.
know,
Yeah.
everything. So it's the CPU, it's the GPU, it's the motherboard, it's all gone. So that's why it's really risky to apply liquid metal on your laptop. That's why a lot of people I think are afraid of it and hesitant to do it, even though there are pretty big gains to be made. Um, but yeah, that's why it's I think really cool for us to be able to offer that out of the box. You already have liquid metal. You don't have to deal with any of this. It's all under warranty, so you don't have to worry about anything going wrong. Even if something should go wrong for some odd reason, it's all covered by warranty, and you're gonna
Nice.
get your laptop fixed or replaced. So yeah, that's really nice.
I'll tell you, I'm not brave enough to try this myself. I just wouldn't do it. Nope. I would mess it up 100% of the time.
Yeah, yeah. I think I'm fine doing it on laptops because I didn't buy them. I work here, so I get those laptops, and if something goes bad, it sucks, and people look at me mean. But at least I'm not short like 2,000 or $3,000. So
Ryan,
yeah,
are you just sucking it up right now? He's just playing with it.
yeah, I'm just trying to
get
save as much
distracted.
liquid metal as possible because our friends at Thermal were pretty adamant on it being
It's
quite
like I
pricey.
do need it back.
Oh no. Well,
It's fine. It's fine. You'll never know. This stays between us.
and the entire internet as we are broadcasting live. Well, this is fascinating. Anything we didn't cover? One thing I did want to ask actually, off the top of my head, is you mentioned that you're going to apply it to the heatsink on a laptop. Would that also be the best way to apply it if you wanted to try to use it on your CPU and your desktop?
On your desktop, usually you have the IHS, the integrated heat spreader. So there's a copper plate on top of the silicon die. So you don't actually see the CPU itself anymore. Like back in the days, you would, but now it's all covered
That's
with
true.
a piece of copper. So you can apply the liquid metal just directly there. You can also apply it on the heatsink. Some people apply it on both the heatsink and on the IHS, and then uh, but
And
there's
there's
also
also the more extreme people that delit their CPUs and
yeah,
then imply liquid metal inside there.
Hmm.
But
yeah.
that's a more complicated process. And
Yeah, but I think honestly that's where you can have the biggest gains, and that's where I think most people use liquid metal. Oh, actually, I don't know if most people, but I would say where you have the biggest gains for sure is when you delit the CPU and you remove the IHS and you apply the liquid metal between the IHS and the CPU die, because that's where that's the most critical point. That's the main bottleneck of cooling the CPU. If you apply it between the IHS and the heatsink, there you already have a much larger surface area for the IHS and then touching the heatsink base. Over there, the gains are not that big. I think you only get like 3, 4, 5 degrees temperature drop. But if you delit the CPU and remove the regular solder or thermal paste that Intel and AMD use, and then replace it with liquid metal, then you really see those gains of like 10 degrees or even more. I've seen some people get like 14 degrees, 15 degrees drop at high CPU voltages, where you're really blasting like 200, 300 watts through the CPU. At that point, you can see even bigger gains.
Gains to be had.
Yep. And yeah, as CPUs tend to turbo automatically higher and higher, and it's no longer that the CPU just runs at one clock, but they dynamically adjust the clock speed that they run at constantly and constantly try to run at the highest clock possible. And whenever that happens, every extra thermal headroom you give the CPU or also the GPU, they automatically just clock higher. So you don't even need to adjust the clock speeds and push them higher yourself and fiddle around with voltages and clocks. That helps, but you don't even have to do that. All you have to do is just cool the CPU and the GPU better, and they automatically bump up their clocks and give you extra performance.
Fascinating stuff. Learned a lot today about liquid metal. I don't think there's much more to dive into on it, though. Just
Yeah, I mean, liquid metal overall, some people ask me if I believe that's the future and everybody's going to use liquid metal in the future. And honestly, I think that there's a high chance that liquid metal will become somewhat of a standard, at least for high-end laptops in the future. For desktops, I'm not so sure, but for laptops, yes. And for example, Intel is already recommending all laptop partners to look into liquid metal. And
really
they've invested in a company in China that's manufacturing liquid metal. And so there's actually there's proper engineering documents and guidelines that recommend using liquid metal and point out the benefits. So I think there are definitely going to be more and more laptops that apply liquid metal, and we might even see it in other applications, such as maybe consoles or some other environments where you have really high performance electronics. I wouldn't be surprised if some servers start using liquid metal.
think so.
Yeah, because for servers, they generally go all crazy on performance, like it's ultra high performance. In servers, we've had water cooling for decades because it was very expensive to do. It is very expensive to do, but you care about getting the best possible performance. There are some server farms that even use sub-zero cooling. So over there, there's a lot of money to be had, and those systems run 24/7. So every little bit helps, and liquid metal definitely helps. So yeah, I wonder if there's some server farms already using liquid metal. I haven't heard anything of it.
It's possible.
I should check with Roman the Bauer. He
Yeah,
probably knows.
yeah, maybe we can investigate. But well, friends, this has been our second episode of ROG Pulse. One of our currently it's our only weekly show, but we've got more that are cooking. They're brewing and they're coming soon. And ROG Pulse will be every single Thursday at 10 p.m. Eastern, 7 p.m. Pacific, 10 a.m.
Friday.
Yeah, for you guys, and Friday. Wherever you live, it's accessible, and of course, it will be on YouTube. So, in general, follow us on social media. Let us know what you guys, want to talk about, and for future episodes. Yes, we are planning an RTX 30 series show. Don't worry, we're looking at doing a live teardown of one of our laptops to really just kind of get in there and talk about breaking it apart, getting into every connection, and seeing what that's all looks like. If you've never broken up a laptop, I actually have never taken apart a laptop myself, so I'm excited for that. And whatever else, we have a lot of interesting peripherals. We've got 360 hertz monitors. We have a lot of different things that we can talk about on the show, and that is a plan here for Pulse. But we're also gonna have a gaming podcast where it's really just general gaming banter. That one's coming very soon, and then we're gonna have weekly gaming live streams where I will play video games. I can't wait for that one. That's going to be a good show. The good life. Sascha, Ryan, any shout outs, any final words?
Yeah, I'm looking forward to that gaming show. You already know what you're gonna play. What's the first game you're gonna play?
I believe
Oh, it's not decided
based
yet.
on, well, no, it looks like it's going to be Star Wars Squadrons. That looks like it's going to be our first
nice.
show right
It's
now.
pretty solid.
So
Very nice.
I'm a big Star Wars fan, and I'm a big flight sim nerd. I have multiple flight sticks, for
Are you
playing
gonna play it
space
in
sims.
VR?
It's a good question. Because I own a Vive, but I would have to set up the base stations because I'm currently in a temporary office.
Yeah.
So I don't know if I want to drill holes for the base stations or not. But maybe. I really want to play it in VR because that sounds super exciting. It does.
You can hot glue them. So what I did is I hot glued them to the wall. It's kind of ugly once you know, peel them off, but that works.
Hmm.
Yeah. I'm really looking forward to that one as well. Yeah, I just pre-ordered the Quest 2.
You did.
So
You pulled the
I
trigger.
can't wait to play. Yeah. So I can't wait to play Squadron on in VR as well.
I just bought a PlayStation 5. Do I want to buy a Quest 2?
Yeah, they came out at like the same time,
I
right?
know. And the
It's like,
3080. It's like everything. It's just like
yeah,
rip
all at
wallets
once.
everywhere.
Yeah, yeah.
Jake, you managed to get a pre-order in, huh? For the PS5.
I did manage to get one later. Yeah.
Wow.
Yeah.
Oh, lucky you.
Lucky you.
Yeah.
I don't know when those will come out here in Asia.
Who knows? Hopefully you guys are, I wish everyone the best of luck when it comes to their hunts for whatever they're looking for. The 3080 is obviously very hard to get on. We have no insight here personally on stock, so apologies on
Even
that.
for us, it's hard to get the
Yeah,
cards.
it
you know?
is. It
Even
is.
for us
So
internally.
it seems like it's hard to get everything nowadays. Like, just across the board right now, it just seems tough to get your hands on. Switch went out of stock forever ago, right? And it's just electronics in general, hard to come by. But I wish you all the best of luck with that. Next week we shall return with our third episode, and of course follow us on social media. Check it out on Twitter to find out what the topic will be. We'll see you then. Thanks for watching.